All right, good morning, everybody, and welcome to part 7 of Unit 2 on the history of artificial intelligence. And today we're going to look at the foundations, the early developments of computers and technology, all the way up to the 1960s, and how it relates to artificial intelligence. All right, so we're going to start with our history of AI before the modern age. And perhaps if we're looking at the history of artificial intelligence, this will give us some insight into where it might be going, as well as looking at the contributions of Canadians to the development of the artificial intelligence wave. So it might be obvious, but artificial intelligence begins with the development of computer science and the development of mathematics. So before the modern age, the dream of creating artificial beings with intelligence stretched all the way back to Greek mythology, with a feature with a creature, something called Talos, which was a mechanical giant, and the craftsman god Hephaestus, I can't say it, which was said to have built automated servants. Ancient and medieval philosophers also explored the nature of thought and reasoning, and that work would later underpin computational ideas in computer science. Long before computers in 3000 BC in China, the abacus was devised to make mechanical arithmetic. So humans didn't have to do the math themselves. They could use a device to help them do arithmetic. Around 700 to 850 AD, a Persian mathematician named, and I'm not even going to attempt it, but his name was the basis of the word algorithm. So he devised some of the very first step-by-step procedures for doing computations. And therefore his name would be the etymology of that word algorithm, which we now have synonymous with the way computer programs are written. By 1630, the slide rule was created to also mechanize arithmetic, and you can still find some slide rules used today. Between the 17th and the 19th century, philosophers Gottfried Wilhelm Leibniz, René Descartes, and Thomas Hobbes speculated that machines could simulate reasoning, mechanical reasoning, reducing it to just symbolic logic, or what they called reckoning. Leibniz envisioned a calculus ratiocinator, a symbolic system for mechanically resolving logical disputes. So we're starting to see humans starting to more and more take logic, calculation, arithmetic, and looking to find ways to automate this. Pre-1900s, before the 1900s, the mechanical devices were created to assist with mathematics and automation. And this included French mathematician Blaise Pascal, who created the Pascaline, and French weaver and merchant Joseph Jacquard, who created the very first programmable automated machine, which was actually a weaving loom. And English mathematician and engineer Charles Babbage, who created something called the analytical engine. Considered one of, if not the very first computer programmer, Ada Lovelace, who was an English mathematician and a countess, worked on that analytical engine and wrote an algorithm, or wrote a program, to compute Bernoulli's numbers, which was considered one of the very first, if not the first, computer program written on one of the very first versions of a computer called the analytical engine. All right, so that's sort of prehistory. So let's move forward now and move into the early 1900s. So in 1936, Alan Turing, who was an English mathematician and computer scientist and was portrayed and seen in the movie The Imitation Game, published his landmark paper, which is entitled Intelligent Machines. It introduced the concept of a universal machine capable of computing any solvable problem, and this theoretical framework became the bedrock of computer science and, by extension, artificial intelligence. So in many ways, Alan Turing is considered the grandfather, or even the great-grandfather, of artificial intelligence. He introduced the idea of a genetic algorithm, inspired by the concept of survival of the fittest, which had three main components as the state of intelligence. One, the initial state of mind. Very much like a child at birth, you have almost a tabula rasa, a blank slate, a childlike mind ready to go. Two, you receive education. So the mind receives education. 3, the mind also receives other experiences not classified as formal education. And he also proposed that machines could have a neuron like element to them in terms of the biology of the human brain. In 1946, Warren McCullough, an American neuropsychologist, and Walter Pitts, an American logician, published a paper that modeled neurons, a binary threshold unit, as simple logical devices showing mathematically that networks of such units could perform logical operations. In a way, this was the first formal model of an artificial neural network, which we looked at in the last unit. In 1948, Norbert Wiener, an American computer scientist and mathematician, published Cybernetics, a landmark book on communication and control in machines and living things, which focused on feedback loops. And in 1948, Donald Hebb, a Canadian psychologist, introduced Hebbian learning, cells that fire together, wire together, which would later become one of the basis for machine learning. During World War II in 1944, the US military, IBM, and American physicist Howard Aiken developed the Harvard Mark I computer. And now the term computer was starting to be used. And then American Grace Hopper, who was not only a computer scientist, not only had a PhD in mathematics and a PhD in physics, but was also a Navy admiral. She worked on programming that Mark I and introduced the idea of programming using regular human or English-like words, and wrote the very first computer manual. In the photo, you can see this 1952 photo of Hopper testing this thing she created called a compiler that replaced having to use stacks of hundreds of punched cardboard to program a computer by using human-like programming languages, which we still use to this day. By 1945, John von Neumann, who was a Hungarian computer scientist, proposed the idea of the stored program, which used the computer's memory and replaced the 10-digit numerical system with a binary 2-digit numerical system for computers. And both of these concepts are still used today. As a matter of fact, everything on the screen here, right? The idea of programming using words, the idea of manuals, the idea of a stored program, and the idea of using binary are still used in our computer technology to this day. All right, so now we're going to move our history up to the 1950s through to the 1970s. So in the 1950s, Alan Turing, as we know, published another piece of writing called Computing Machinery and Intelligence, formed the backbone of what we now call machine learning. And he devised something he called the Turing test, which is actually the basis of the movie, because the Turing test was also called the imitation game. So simply put, can a computer fool a human into thinking it is also a human? So in the graphic here, you can sort of see how that could go, where you would have someone in between a person and a AI agent. They weren't using that term at the time. And the human would talk to the machine, and the machine would respond back to the human. And the idea was, in the imitation game, could the responses generated by the machine fool the human into thinking they were speaking to another human? And this was known as the imitation game, or the Turing test. By 1954, Wesley Clark, an American physicist, and Belmont Farley, a teacher at MIT, delved into the basics of the neural network and worked on pattern recognition. As well, Gerard Deneen, an American mathematician, and Oliver Selfridge, an English computer scientist at Lincoln Laboratory, started to focus on teaching computers to recognize shapes and to clean up images. Also around this time, Frank Rosenblatt, an American psychologist at Cornell University, coined the term perceptrons, which we've seen again in our previous unit. These pioneers in the 1950s could be considered the preschool teachers of the artificial intelligence movement. But in 1956, a conference was held called the Dartmouth Conference, which was a summer workshop considered the foundational event of artificial intelligence. Some consider it the birth of artificial intelligence. This conference was put on by what could be considered four American founding fathers of AI: John McCarthy, who actually coined the term at the conference, artificial intelligence; Claude Shannon; Marvin Minsky, all computer scientists; and Nathaniel Rochester, an electrical engineer. By the 1960s, after this decade of change, and up to this point, well, computers didn't really have a viable way to save information. So they had a lot of great ideas, but as Alan Turing put it, they were like these infants who would learn something and then immediately forget what they learned. So the hardware technology hadn't really caught up to the ideas they were proposing. In the United States, the Defense Advanced Research Projects Agency, or DARPA, would step in with some funding. DARPA provided the financial support to continue this research at MIT and Stanford and Carnegie Mellon at the universities. And in 1962, Arthur Samuel, an American computer scientist, used IBM's 7094 computer and faced checkers master Robert Neely in a match that was televised, demonstrating and coining the term machine learning, and showed that the computer could not only execute pre-programmed instructions, but also adapt and improve through experience. The research in neural networks and symbolic processing, and a big emphasis on language processing, started to take place. John McCarthy, who was at the conference, conceived of a programming language called Lisp programming, which is still somewhat used today. Lisp made significant improvements to the coding process. And then in 1966, Joseph Weizenbaum, a German computer scientist at MIT, created ELIZA, which was actually named after a movie released at the time called My Fair Lady. And it used natural language processing, sometimes called NLP, and optical character recognition, sometimes called OCR, to recognize language and to see characters. The program could be considered the very first chatbot. Also in the 1960s, American statisticians Evelyn Fix and Joseph Hodges, later would expand upon by physicist and physicist professor Thomas Cover, something called the K-nearest neighbor algorithm, which would search for things around something, and it became a key component of artificial intelligence in later years. A statistical algorithm where objects are classified by a plurality vote of the neighbors would factor into the supervised learning method that we've studied in the previous unit. So you can see the remnants of this algorithm today when you search for something online and it gets ads that are similar or near the item that you were searching for popping up in your social media feeds. This was the K-nearest algorithm that was developed. By 1969, Stanford researchers developed a physical robot that incorporated AI. It was called Shaky the Robot, and it could reason about its actions, it could follow instructions, it could learn, and it could plan out routes to travel. It was the first of its kind that worked autonomously, in other words, without a human operating it or remotely. And guys, that's the early part of the history of artificial intelligence. I hope you liked it, and I hope you have a great day.